this lesson, you are going to learn how to solve logarithmic equations. So let's begin by looking at an example that contains just one log. Now, your goal should be to isolate the logarithmic part of the expression. So I'm going to do that by first dividing both sides by 2, which produces the ln of x is equal to 9. Now, from this point, there's 2 ways you can do this. You could think, well, let's change this to exponential form, where you think about the base and you do your counterclockwise motion. So the base is e, so this is saying that e to the 9th power is equal to x. And e to the 9th power, if you put that in your calculator, is 8,103.08. Now I'm going to show you a second way. So first divide by 2 gives you the ln of x equals 9. What you could do rather than changing to exponential form is exponentiate, which means you're going to use a base on either side. So I would choose the same base that's in the problem. So the current base is e. So exponentiating is, in a sense, what was there becomes the exponent, and now you have a base, and you've done the same on each side. This is called exponentiate. Why would we do that? Well, this is inverses. An exponent raised to a log of the same base, they undo each other, and we just get on the left side that x, and on the right we have e to the 9th. So it's really whichever method you prefer. Neither is really more steps. It's just probably exponentiating is kind of a new concept to you. Okay, a little more complicated. Again, I'm going to begin by trying to isolate my log portion, which is right here. So I'm going to begin by subtracting 7, which would give me 6, and then I'm going to divide by -3. So that gives me log of 10x is equal to -2. So now that I have it, the log isolated, I can either change to exponential form. So I'll show that over here. So my base would be 10. So this is really saying 10 to the -2nd power is equal to 10x. Well, 10 to the -2nd would be 1/100th, and then I need to divide by 10 on each side. I'm just going to write it like this, so I can see that I would get 1/1000th is equal to x. Or you can write it as a decimal if you prefer. Now, let me just show you same logic here, but doing this process where we exponentiate. So I would use the same base that's in the problem. So it's common log, so I would do 10 to the log of 10x is equal to 10 to the -2nd. And why do I do that? Well, I have an inverse right here. 10 to the log of base 10 of 10x will undo each other and just leave me with 10x is equal to 10 to the -2nd. So I could divide both sides by 10. I get x equals, keep my base, subtract my exponents, would be 10 to the -3rd, which is also 1/1000th. Okay, so you kind of, pick the method you like best and do it well. So one more just to illustrate that the base doesn't need to be the common log of 10 or the natural log using e. This has a base of 5. So I'm going to begin by doing my power rule to bring the 4 out front, which would be 4 times log base 5 of x is equal to 20. Now I'm going to divide both sides by 4, which gives me log base 5 of x is equal to 5. And now I'm going to exponentiate. So I'm going to use the same base on either side. So log, or 5 raised to the log of base 5 will undo each other, and give me just x. They're inverses. So I have x equals 5 to the 5th power. So x is 3,125. So how does example D differ now? As I scan this, I notice I have multiple logs, okay? So one of the things I do is I check and see, are the bases the same on my logs? They are. That's going to make things a little easier. And then I look for where's my variable, and it's embedded then in that log. So my plan is typically to get the x or the variable on one side and everything else on the other side. So what I'm going to do is I don't like my log to be have a negative coefficient, so I'm going to bring that over to the left. So that would give me positive, if I add it to both sides, log base 2 of x minus 4. And then I'm going to subtract log base 2 of 5 from both sides. So I'll recopy the log base 2 of 10 minus log base 2 of 5. Okay, so on the right side, like bases, and they're held by subtraction, so I'm going to condense the right side using my rules for logs with like bases. So it's subtraction, that means the argument would be division, 10 divided by 5, which is 2, right? So I have log base 2 of 2, and on the left I still have log base 2 of x minus 4. Now, hopefully you spot something on the right. Think about it. What is log base 2 of 2? Remember, this is saying that 2 to some power is equal to 2. Well, that's 1, right? So I have log base 2 of x minus 4 is equal to 1. Now I have just one log in the problem. Two ways you could go from here. You could change it to exponential form, or you exponentiate. I'm going to exponentiate using a base of 2. And when I do that, this undoes each other, and I have x minus 4 is equal to 2 to the first, which is just 2. Yay, all that work gets down to just x equals 6. Now, of course, one of the things I always do is I check my answer. If you have a calculator that allows you to use a log base 2, which most graphing calculators do, it's hidden in the math feature, just type it in there. Otherwise, you've got to use your change of base formula. Take a few seconds and check it. And sure enough, it does work. When I check it, I get approximately 2.32 on both the left and the right side when I substitute in. So x equals 6 is my solution. So as I begin number 5, I notice my variables are both on the left and they're part of the argument. So I notice this is both log base 5 of an argument on the left and the right. So the only way this is true, this is actually a one-to-one property, is if x squared plus x, that argument, is equal to 20. And what do I have now? Well, this is quadratic equation. So let's pull out some things from our tool bank here. I'm going to subtract 20 from both sides. I'm putting it in standard form. And lo and behold, that left side's factorable. And you thought you might be getting away from factoring finally. Gives me what? X plus 5 and x minus 4. Therefore, my solutions are x equals negative 5 and 4. So I'm going to do the check here by plugging in negative 5. So negative 5 squared is positive 25. Minus 5 is 20. So I get log base 5 of 20. And sure enough, that equals the right side. That's identical to what's on the right. And then I'm going to plug in, so this one satisfies, I'm going to plug in 4. Log base 5 of, let's see, if I put 4 in, that's 16 plus 4 is 20. So I get the same thing on either side there. Again, I have multiple logarithms. So I'm kind of glancing at this. What am I going to do? I got 2 variables and they're both on the left. So I'm going to try using some rules here to see if that helps me simplify this. And you know, sometimes you try something and you hit a dead end and you got to rethink it and think, well, what else is legal? So I can, since I have logs of the same base held by addition, that's equivalent to my product rule, which would mean multiply my arguments together. equal to log of 28. So these have the same base. So my conclusion is that x times x minus 3 is equal to 28. So I'm going to make that x squared minus 3x is equal to 28. Again, I've got a quadratic. So x squared minus 3x minus 28 equals 0. I'm going to factor this if possible. If not, I guess I'm going to the quadratic formula. Don't worry, I think most of them are factorable. X minus 7 and x plus 4. Yep, that works. And then, so x is 7 or negative 4. And I'm going to take a second and plug this in and make sure it satisfies. And so here I go. I'm plugging in 7 into the original equation. Log of 28 is 1.45 approximately. And then I'm going to do log of 7 plus log of 4. And sure enough, yep, that's 1.45. And then I'm going to do this again. And when I plug this one in, I have log of negative 4. And I cannot take a log of a negative. So this is an extraneous solution. It looked like it worked, but it does not satisfy the original equation. So x equals 7 is my only solution. Okay, here's another one with multiple logs, and I scan and I'm looking for my variables, and I see that x is in each of the arguments. So I'm going to just kind of proceed here and see what we can do. Let's start on the left side. What can we clean up? It looks to me like we can use our quotient rule. So this would be the ln of 7x plus 3 over x plus 1 is equal to the ln of 2x. So what's that give me? Well, I've got a log with the same base on either side. So the arguments by the one-to-one property are equal to one another. So I know that 7x plus 3 over x plus 1 is equal to 2x. So I just completely got rid of the logs. Okay, so I'm going to make this a proportion and cross multiply. So this would give me 7x plus 3 is equal to, on the diagonal here, 2x squared plus 2x. All right, so to solve this, I'm going to bring everything over to the right, which gives me 2x squared minus 5x minus 3. And let's see, I'm going to factor this. I'm going to try 2x and x. And I'm going to do 3 and 1. And I'm going to, let's see, yep, that's going to work. Outer product would be negative 6. Inner product is positive 1. That's going to add to negative 5. So I'm in good shape here. So that gives me x equals, let's see, negative 1/2 and 3. Now, let's go and see what happens, especially this negative 1. We got to be cautious about. If I plug that in, this negative 1/2, am I going to have a negative argument anywhere? I sure do. 2 times negative 1/2. I'm not going to be able to take the ln of negative 1. That's non-real. Okay, so I know that this solution here is extraneous. So x equals 3 is my only solution. Okay, it's your turn. You've got to practice working your way through these. So when you are ready to check your answer, hit play. So hopefully you notice on the left, we have variables embedded in both arguments, and our logs have the same base. So we can use our product rule. So that's going to be log base 12 of 12x times x minus 1 is equal to 2. So now I only have one log, so what am I going to do? Well, I'm going to either, let's see, exponentiate or change to exponential form, whichever you prefer. So I think the last two I exponentiated. I'm going to change to exponential form on this one. Both will get me the same answer. So 12 squared equals 12x times x minus 1. So I've got, I'm going to distribute here. That's 12x squared minus 12x. And this right here is 144. I'm going to subtract it from both sides. And let's see what we can do from here. I'm going to factor out my greatest common factor. x squared minus x minus 12, and this is much more doable. X minus 4 and x plus 3 would add to -1 and multiply to -12. And by the zero product property, x equals 4 and -3. And I'm going to check and see if any of these are extraneous. And let's see. Sure enough, when I plug in -3, that would produce a negative argument right here. I'd have 12 times -3. So that's going to be extraneous. So x equals 4 is my only solution.